Alright, so welcome back. I'm going to try to do at least until 12, maybe 12:30, another video. So now we're going to be doing internet access for real. So let's do the same thing we do and do a help apropos. Here we go. So we've got examples internet. Looks like we've got lots of good stuff to dive into. Yeah, lots of different kinds. So I'm not sure which kind will be on the test, but we'll look into all the different kinds. We'll just try to narrow down which ones will be good. Okay, well, we'll start with this one here. Layer 3 VPN internet access examples. Juniper software supports internet access from a Layer 3 virtual private network, VPN. This chapter provides examples that demonstrate how to configure a provider edge PE router to provide internet access to customer edge CE routers in a VPN. The method you use depends on the needs and specifications of the individual network. To provide internet access through a Layer 3 VPN, you need to configure policies on the PE router. You also need to configure the next table statement at the edit routing instances, routing instance name, routing options static route hierarchy level. When configured, this statement can point to a default route from the VPN table, routing instance, to the main routing table, default instance, inet.0. The main routing table stores all internet routes and is where final route resolution occurs. There are several ways to configure a PE router to provide CE routers access to the internet. These types of access are described in the following sections: non-VRF internet access, distributed internet access, centralized internet access. Okay, so I'll mark this off. Okay, and then, yeah, it looks like we've got a whole bunch of different kinds through natting, through private VLANs, through separate interfaces, and then we've got PE Layer 2 internet, CE without PE, CE hub. This looks like, yeah, so we've got all different kinds. Let's look at these two kinds. So PE router provides Layer 2 internet service. In this configuration, the PE router acts as a Layer 2 device providing a Layer 2 connection, such as Circuit Cross Connect, CCC, to another router that has a full set of internet routes. The CE router can use just one physical interface and two logical interfaces to the PE router, or it can use multiple physical interfaces to the PE router. See PE router connects to router connected to the internet. Oh man, I'm tired. CE router accesses internet independently of the PE router. in this configuration, the PE router does not provide the internet access. The CE router sends internet traffic either to another service provider or to the same service provider but a different router. The PE router handles layer 3 VPN traffic only. C, PE router does not provide internet access. So these images might be useful. I won't be able to look at these during the test, but right now they're going to make the picture more clear, I think. Okay. Okay, so this is return internet traffic through a different interface. In this example, the CE router sends VPN and internet traffic through the same interface, but receives return internet traffic through a different interface. The PE router has a default route in the VRF table pointing to the main routing table inet.0. It routes the VPN public IP address pool, return internet traffic through a different interface in inet.0, see VPN, and outgoing internet traffic routed through the same interface, and return internet traffic routed through a different interface. The CE router still performs NAT functions. Configuration for router PE1. This example has the same configuration as router PE1 in routing VPN and internet traffic through different interfaces. It uses the topology shown in the example of internet traffic routed through separate interfaces. The default route to the VPN routing table is configured differently. At the edit routing instances, routing instance name, routing options hierarchy level, you configure a static route that is installed in VPN a.inet.0 and points to inet.0 for resolution. You also need to change the configuration of router CE1 from a configuration that works with the configuration for router PE1 described in routing VPN and internet traffic through different interfaces to account for the differences in the configuration of the PE routers. Okay, so let's pick one of these. So we've got many CE hubs, we've got Public-vpn, we've got Nat-device, we've got private VLAN, we've got separate interfaces, and we've got CE hub. So, and then of course we've got these as well, but let's use one that has configuration summary included. So maybe just the first one, just because I don't know if one is better than the other, so we might as well just go with the first one. Although I would like to use NAT. I haven't used NAT in like hardly ever, so just for like studying for the exams is when I've used NAT, so I kind of want to get more familiar with it. Okay, this looks okay. So we've got let's see here. So we've got PE1. We've got PE2. And we've got PE3. So we've got 3 PEs. Okay, so let's do that. We've also got like this for a public VPN. Oh, okay. Yeah, this is what I needed, I think, when I had problems with it not being in the right INET table. It was in INET.0 and it was meant to be in INET.3. I think I needed a rib group to import it to INET.0. God damn it. Okay, so I want to do one that has a rib group because I want to check my understanding on that. So does this one have a rib group? Nope. That one has it. That one doesn't. Let's see, Private-vpn has it. Private-vpn has it. Okay, so we're gonna say types of configuration. Why does it apply things to... Okay, there we go. But now it's got... Okay, there we go. So types of configuration, we've got many C hubs, we've got Public-vpn, we've got Nat-device, we've got Private-vpn, we've got separate interfaces. Okay, so clearly I'm not gonna have time to go through all of these, but well, let's pick out at least one of them. Yeah, so this one looks good. We'll go with the public and the private so we can see the difference between the two more clearly. And both of those have rib groups, which is definitely going to be a part of this exam. Rib groups had their own actual topic in the curriculum, so it's going to be absolutely necessary to learn about. So yep, this is going to be this video. We're going to have we're going to go and set up these labs here. So let's take a look at the configuration summary for this first one. Okay, so in this configuration we're going to have PE1. Oh, is that it? I thought there were more than just one PE. Oh, I see. Okay, so it looks like in order to get the configuration, like the main configuration that a lot of these are based off of, is wish this weren't so needlessly difficult. Yeah, it's this one here. So let's grab that, and then we'll do a Control Y. Oh shoot, that was a Control Y ending action. Oh shoot, that really sucks. Yeah, that was a Control Y ending action. Well, I remember what this was. So this is private VLAN, and then this is separate interfaces, and this is PD layer 2 internet, and then this is okay, so we can get rid of this, get rid of that. Okay, so yeah, that looks good. Okay, so this looks like it's going to be the main source of a lot of things. Let's see if we've got rib groups in this one. If we do, I might as well just do this one. There's no rib groups in this one. But just like, okay, so here we only have configuration given for PE1. Okay, so let's try this. Okay, so let's try just simplifying this topology. We're moving on from the last example. Okay, so let's try just setting up a regular old L3 VPN, because I think that's what all of these are going to be based off of. So we're going to have CE routers here. These are both going to be CE routers. Okay, and then here's our L3 VPN. So we're going to have PE routers and P routers, of course. Okay, so these are going to be the PE routers, very clearly. And then these are just going to be P routers. So this is going to be the thing. I'll just set up a generic connection, but I'll do that after I take a quick break. I'll be right back. Alright, I'm back. let's get working on this. So I'm gonna blank out all these routers, and then I'm going to, I kind of want actually a third PE to C connection. So let's set that up. I can get rid of all these links. Okay, so we've got 9 routers. So if I have 6 routers, we'll have 3 more to mess around with. So let's make it more. So we've got 1 and 2. Let's have it so that we've got 3 and 4. Okay, and then let's have it so we have 5 and 6. Okay, so here's our PE to CE connections. So let's connect those up. They're going to be on GE00 for each of these. Okay, and then we're going to have these all blanked out as well. So let's blank these out for now. Oh, you know what? This is my cron job. I have a cron job every day, including the weekends. So these are gonna reboot. It's gonna take a while for them to do that. So I'm gonna pause it and I'll be right back. All right, welcome back. Oh yeah, I've got Citizen Eatery up on my screen because I was thinking about dinner. So yeah, I've got that scheduled. Yeah. I'm back from a kind of an extended break. What happened was I was in the middle of configuring these routers, and then my cron job kicked in at 11:30. So I've got another cron job kicking in at 4:30 today. So I'm planning to just spend this 3 hours until then, and then I'm getting a treat to good dinner once that cron job kicks in. So where I was left off before that cron job kicked in. And I apologize, I meant to come back earlier, but I just jumped in Allspace VR and I was having a really interesting conversation. So I'm back now though. 3 hours is going to be plenty of time to finish up this topic, and then either this evening or if I can kind of have haste. I think my goal of finishing 2 topics today is going to be more than achievable. So yeah, let's get right to it and clear off these routers. So this is probably the biggest flaw in my study strategy. I just have a lot of downtime where I'm like just waiting for this commit to go through, or I'm just cleaning up my lab, or I'm rearranging the icons. I wish there was something I could do about that, because that does, I would say, that does eat into a very large percentage of my study time. I would say every hour I put in at least 20 minutes of that, if not even a full half of that time, is devoted to just this kind of clerical stuff that has no value in the final pass or fail likelihood equation. In fact, it sides more on the fail equation, fail outcome side, because I haven't put in actual work. Especially now, me not understanding INET3 and INET0 rib groups and like all that, and how they fit into play, and like the family INETs, not having a full understanding of that. It's like I need to be working on that. But that's what we're gonna do. We're just gonna kind of go our own way here and just come up with a basic generic L3 VPN. Get everything to work the way it's meant to work. I even got some notes here from a coworker of mine who's been studying for this exam. So I'm basically going to look at those notes, and I'm just going to look at like online stuff and just try to come up with a basic functioning L3 VPN. I tried this before and I failed at it, but I think I'll have a better time with it this time around, because I've got more confidence with it. And then once I get that basic L3 VPN, we'll pull up these help docs and see what changes I need to make. Okay, so we've got all of these routers now cleared off. We're going to need to clear off these two more. Okay, so perfect. Let's arrange these now. We'll have yeah, let's even get rid of this just to make it more just as sensical as we possibly can have it. Okay, so our outer layer is going to be the PE routers. So we'll have PE router 1, PE router 2, and then PE router 3 here. Okay, so we'll form like a triangle with that. Like this looks good. Okay, and then we're gonna have an inner layer of PE routers, so connecting to the CE routers. So we'll have 1, 2, 3, 4, 5, and 6. Okay, and then 7 and 8 are going to be P routers. So we'll have 8 there plugging into both of these, and then we'll have 9 plugging into this one. Okay, so this should work. So, and then the outer layers are going to be 0 to 0. All right, and then the inner, so it'll be 1 to whatever it has to be. So let's do 1 to 0. Yeah, so we'll do 1 to 0 here. Then we'll do 1 to 1 here. Actually, let's do this. So we're going to get rid of this. Get rid of that. So we're going to do 0 to 0 here between these two. Yep. And then we'll do 1 to 1 here. Yep. And then 1 to 1 here. And then 2 to 1 here. Okay, so this should work. So yeah, this is going to be the topology. So let's make it even more extra super clear and add yeah, so that we know that these are customer sites. We'll add these rectangles here. Because I just want it to be extra super 100% clear, and I want to kind of understand this once and for all here. Okay, so we're good to go. Yeah, and then this is all our L3 VPN, so I can even maybe like draw a circle. Okay, and then this is the actual yeah. So I think this makes sense. So hopefully this makes sense. So yep. Now let's configure the links. We're just going to use for the PE connections. We'll use 10.0. Yeah, we'll use 10.0.1 .2, and .3 for the PE connections, and then we'll use 10.1, .1, 2, 3, and 4 for the core link connections. Alright, so let's do that. Oops, I accidentally hit the Open All console button. Alright, but that's not the worst thing in the world. In fact, that's actually going to work. Okay. Okay, that looks good to me. Let's commit that. And on .4. Okay. Okay, so we're good to go with our first ring of addresses around the outside edge, which is the PE to CE connection. So now let's focus on the core links, which are going to be .1. So .1, .2, .3, and .4. Starting on router 4. Okay, and let's add descriptions. Customer facing. Core facing. Okay, looks good to me. So we're going to need to jump over to router 8. I will need, yeah. Okay, time for router 5. we're gonna do. Oh no, sorry, I messed up the convention. It's gonna be. So here it was .0, .1, .2, and .3, but here's going to be .1, .1, .2, .3, and .4. So I screwed it up. I guess I started at .0, which I guess would be okay, but I guess you know what? I'd rather start it at 1 the way I had initially planned. So let's just stick with the plan and let's switch this over to .1. Okay, so yeah, it's going to be .1, .1, .1. Okay, rudder 8. And this is going to be .1, .1, .2. Okay, and then this is going to be .1, .2, .1. Okay, and then rudder 8. Okay. Yeah, so .1. Actually, let's use a different convention. We're gonna have .0, .1 here, .2, .3 here, and then we're gonna have .1, .1 here, .2. But now let's make this one .3, and then let's make this one .2, .2, because this is a pure P2P link. It's a different type of link, so let's treat it with a different type of subnet. So yeah, so we're going to move over here and we're going to be .1, .3. So let's start on router 6. Okay, so .0. Oh, sorry, no, it is going to be .1. Okay, so set family inet just 10.1.3.2. Perfect. Okay, so now it's time for the link connecting router 8 and router 9. It's going to be a different kind of link. It's going to be so we've got multiple kinds of links, and I'll list all the kinds of links we have in this notepad. So we have CE to PE links. We have PE to P links. And then we also have P to P links. So we've only got 3 different kinds of links in this topology. So for the CE to PE links, we're using 10.0.1, 2, and 3. For here, we're using 10.1.1, 2, and 3, because we've got 3 of these links here, and then we've only got 1 of these links here, so we're using 10.2.1, that one. Hopefully that is nice and clear. So router 1. Okay, perfect. We're good to go. We've got all the links in there cabled up, so everything should be good in that regard. We're also going to need a IGP, so let's do that. We will eventually need loopbacks to form BGP connections, but for now, let's just stick to the basics. Okay, yeah, so let's set up Ospf. And we're only going to need the core-facing link. So, yeah, let's simplify things and just open the ones we're gonna need. So basically, we're just going to configure the core links on the CE right now. So we will need family MPLS on those, so let's set that up. Okay, and then we'll need protocols Ospf, and we'll need traffic engineering turned on. We can use ISIS as well, but I'd rather use Ospf. It's a little bit easier as long as you remember traffic engineering. And then you can do show TED database. That's a really important command. Don't have anything yet. Okay, so yep, now we need set protocols. We can use Ldp or Rsvp. I'd rather use Rsvp. I'm more comfortable with that, and then the manual. You know what? Let's use Ldp just because I'm more comfortable with Rsvp. It might. You know what I think might have been the problem? Because I didn't have protocols Ldp enabled. I don't know. I'm so confused. I'm just really confused right now. We're going to go with Rsvp. Well, no, here's a point of contention. So I don't know whether to go with Rsvp or Ldp, and to be honest, I don't even think it really matters that much. Let's do a help apropos for L3 VPNs. Yeah, so here's where I can make a decision. I could have made a decision before as well between Ospf and ISIS, but here I can make a decision between Ldp and Rsvp. And I'm tempted to use Rsvp because I guess I'm a little bit more comfortable with that one, but it does require more configuration than LDP, and right now I'm just having problems with the simple basics, getting that to work, so I'm almost wondering if simplifying things would be the right idea. So it looks like this help command isn't working. So let's try to get the CLI prompt back. We can try it on a different router where I'm not in configuration mode. There we go. Looks like there's just a lot of hits. So let's try match all three. Okay, we're going to go with Rsvp. Okay, so we're going to start at the bottom and just get Ospf to work. So I'm kind of thinking of this as like layers of an onion all coming together. So right now we've got our INET0 table filled up with our direct connect routes. We've also got our MPLS table filled up. So the next table, or the next thing I want to happen is the INET.0 table to fill in with the Ospf routes. So I'm going to add this exact configuration here to the other PEs. Okay, so we also need to add that sort of configuration to the PE routers, but it's going to, we can do an interface all on those. Okay, so let's start with Rudder 8 and then do Rudder 9 next. 158, Rudder 9. Okay, so now we've got hopefully RSVP neighbors, Ospf neighbors. Oh, we still got a Ospf neighborship that's coming up. It's in two-way. Xstart. So this is interface 0. So to R9, it looks like it might be having some problems. So the address is 212.211. Okay, so that, oh, okay, it just took some time. It's in full. I really hope I get pipe refresh on the exam. That would be so amazing. Oh, without pipe refresh, that would be like devastating. Maybe I could do like an OP script to build it on my own. Okay, so we've got everything good. And now we've got, yep, so we've got all the missing routes. So on Rudder 4, we should have 1, 2, 3 routes now in the Rudder 4 table, inet.0 table. So it looks like I'm missing one. Oh no, it should only be 3. Okay, perfect. So yep, I've got everything. So the next step, I think, will be I guess I want it to be the routing table, or the actual BRF routing instance. Now, instead of a VRF, there's also a virtual router. Let's just stick to VRF though. Okay, so we've got to have a route distinguisher now, so that's going to be based on the loopback. So let's do 192.168.0. Or let's do dot 1, dot 1, 2, and 3, and then for these we'll do dot 0, dot 1, 2, and 3. Okay, and then we'll have the autonomous system be 100. Okay. So we need a VRF target as well. So we'll make one target, 201. Or sorry, this is going to be 100, so 100. Alright, I think that's all I need. Oh, I also need to add interface to it. And it's going to be the customer-facing interface. There we go. Alright, so let's add this to the other ones. Oh shoot, have I been using /30s for all of them? I hope not. Oh, I have been. On this one, I got it wrong. Okay, you know what? I think I'm gonna, because I think this is just gonna get off the rails. Like, I've tried this before, and I didn't get very far, so I'm just afraid that I'm going to try this again and do exactly what I did last time and just be confused and not do it right. So... I don't know what this service means. Yeah, this I have no idea what's going on. Okay, so I'm going to use this as a guide. I'm getting kind of lost here. So these devices are fine. I'm not. They went with LDP. I decided to go with RSVP. It looks like they have a group here for some reason. On the P router, is that necessary? Why do they have that? I don't think that's necessary. Oh, they have a route reflector as well. Why do they have a... Yeah, why do they have BGP on these? I thought they would only need them here for end-to-end. What do they even have the neighbor to? They only have one neighbor statement, and it points to... Oh, it points to the route reflector, 4.4. Yeah. Okay, so it has all of the routers pointing to the route reflector, which kind of makes sense. I didn't think you needed it on all of them, though. I thought you only needed it on the P's. Oh my god, I'm so, like, I'm feeling so over my head right now. And I've got all of L2 VPNs to go still. I haven't even gotten to that section yet. It's going to be a huge section. I haven't even gotten the multicast. It's going to be huge. Another thing that's going to be huge is oh, I can't think of what it is for some reason. Oh yeah, class of service, that's going to be huge. So I'm just kind of feeling overwhelmed right now and in over my head, and this topic is kind of beating me. I'm feeling defeated. I'm going to pause it and get a glass of water and come back. Hopefully I won't be gone for too long. Alright, I'm back. Let's keep going on this. It's a little bit warmer in here. I won't need this sweater anymore, so I'm going to take it off once my desk is all the way up. Okay, and then we'll try to get things going here. I guess I'm not sure. Yeah, so let's set this up. It's going to be L3 VPN with route reflection and AS override. Route reflector is going to be Rudder 8. So let's configure the route reflector. Okay, and this is going to need a loop back as well. So we'll have this be .192.168.2.1, and then we'll have that 2.2. Okay, so now we can establish BGP connections. So let's establish our full mesh of neighborships. We're going to use that using a route reflector. So let's do that. Okay, so that should be good. And then we're just going to need one statement for the rest of these. Oh, we need a local autonomous system. Gonna need that on Rudder 9 as well. Okay, so I think I'm good to go. I do need something else. Oh yeah. I need the other routers to peer to the route reflector. Okay, so that should be enough to have the neighborship come up. Let's take a look at that. And I think this is the problem I was having is the VPN routes are going to be exchanged through BGP. So you've got to have your BGP neighborships set up a certain way. Otherwise, they won't be able to exchange. Like, that's where your traffic is actually going through. And I think I had a misconception of that because I had thought that they were going through the VPN. I actually don't know. I wish I understood this better. Okay, but we can repurpose this, make the configuration a lot faster on the other ones. Okay, so now we're gonna have .1, 2, and 3. So let's start with the .1. Okay, and then .2 and .3. All right, and then .3. Okay, and we'll go on the route reflector to check the neighborships. So we can check them all at once. That's interesting. Oh, you know what? It's because I don't have the loopbacks included in Ospf. So if I do a show route, we don't have the loopback addresses. Or sorry, if I do a show route protocol Ospf, it doesn't show up. We don't get loopback addresses in there. There you go. Okay. Okay, so that I just need to add that to the configuration. Oh, but I do have, okay, I have it on this one, but I don't have it on all the other ones. Come on, please. There we go. Okay, we'll probably need it in these other protocols eventually as well, so I might as well just add it to them now. Okay, and I'll make it easier on myself. Okay, so now we should have the loopbacks in there. Okay, we do have the loopbacks in there now, so now the neighborships should be up. Okay, we've got one more that's still on its way. It's an open firm, which usually means it's good. So yep, all our neighborships are up now. So so everything is good to go. Oh, you know what? I probably will need to use LDP. I don't know what this deaggregate means. Oh, it has to do with oh. Yeah, I'm like freaking out because like the test is in a month, and am I gonna remember LDP deaggregate? Like, I don't think so. Like, yeah, I'm freaking out, man. And like, it's just, oh, I just feel like my life is falling apart right now. Oh, and I didn't vote to. I just, well, yeah, I should be. Yeah, yeah, okay, well, let's keep going on this. Yeah, you know what? Let's switch over to LDP because otherwise I think I'll have to have a full mesh of pseudo wires, or not pseudo wires, LSPs. Oh man, this is just so nuts. I don't know how I'm gonna pass this. There's so much information on this test. Wow, okay. Yeah, I don't know. I'm not feeling very confident right now. But yeah, let's switch over to LDP instead of RSVP. Okay, so let's do that. Okay, and then it's going to be set protocols LDP deaggregate is the recommended setting to use, so we'll use that. I have a feeling what's going to happen during this test is like I'm going to have so many instances where it's like right on the tip of my mind, like what it is, and then I just strain my brain to recall what it is, and I recall it, and it's something like deaggregate, and it's like not even relevant. Like I'm working on QoS or something, and I strain my brain to remember a knob, and I remember the deaggregate knob, and it doesn't even matter for the section of the test I'm working on. deaggregate. Okay, so hopefully things are better now. I'm not sure how to verify my... Yeah, now that I've got an INET3 table. Yep, learning through LDP, okay. I think that's good verification. I do see that I've only got, I appear to be missing .3 for some reason. Maybe, yeah, I'm on Rudder 4, I appear to be missing, okay, it just took a while for it to pop in there. Okay, so, okay, that looks better. Perfect, okay, yep, that's gonna work for me. So, yep, we've got the IBGP peering set up. We've got that, so we're pretty much good to go. We're good to go on all the P routers. So now we just need the routing instances. Which I think I already worked on. Okay, we don't even need, yeah, I still have that. I already have that, so we don't even need, okay. Oh, yeah, okay, well, what? Oh, excuse me. Oh, okay. Oh my God. Wow. Okay. Oh, I may need a sweater again. Yeah, I don't know. I think I just need like some exercise or something. I'm not feeling super well. I haven't left the house in a long time. Okay, so let's do, we've got R4, which is a PE. Okay, so I think we're good to go. The only reason we wouldn't be exchanging routes right now is just because I don't have anything. Let's look at the verification steps. Okay, so they want to check the, so show route, table, VPN.inet.0. Oh, okay. Well, where was that special like BRF table? It was like BGP dot something dot something. I don't know, man. I'm really confused. But I think this is right. This is the most simple, basic L3 VPN VRF topology you can have, and then of course I would make connections to the CE, and I would bring in traffic. Let's do that. Okay. Okay, so we'll set up a route similar to this one on the other routers. Okay, I've got my money's in a bunch. Let's see here. Okay, so we're good to go. Yeah, I don't get why I'm not learning the other static routes. I thought that would happen. I'm so confused right now. I have no idea what's going on. I am so confused, and I'm not even studying. Like, I completely stopped looking at. Yeah, I switched over to this like special. Yeah, I'm not even looking at enabling internet access. You know what I'm gonna do? So I'm gonna just read this whole thing, and I might even just call it at that and skip the hands-on for this, because I'm just so confused. I don't even know what to do. Everything I've been doing has just been leading to more confusion. So let's just read this. Enabling internet access for layer 3 VPNs. This topic provides examples on configuring a provider edge PE router to provide internet access to customer edge CE routers in a VPN, and configuring a router to route internet traffic to CE routers through a network address translator, NAT. The method you use depends on the needs and specifications of the individual network. Non-VRF internet access through layer 3 VPNs. Junos OS supports internet access from a layer 3 virtual private network, VPN. You also need to configure the next table statement at the edit routing instances, routing instance name, routing options, static route hierarchy level. When configured, this statement can point a default route from the VPN table routing instance to the main routing table default instance inet.0. The main routing table stores all internet routes and is where final route resolution occurs. The following sections describe ways to provide internet access to a CE router in a L3 VPN without using the VPN routing and forwarding VRF instance. Because these methods effectively bypass the layer 3 VPN, they are not discussed in detail. So CE router accesses internet independently of the PE router. In this configuration, the PE router does not provide the internet access. The CE router sends internet traffic either to another service provider or to the same service provider but a different router. The PE router handles layer 3 traffic only. Okay, so this is the easiest one. In my topology here, say we have this PE here that wants the internet, so just instead of getting it from this whole god-awful mess, it would just get it from somewhere else. Okay, the other option we have is the PE router provides layer 2 internet service. In this configuration, the PE router acts as a layer 2 device, providing a layer 2 connection, such as circuit cross-connect, CCC, to another router that has a full set of internet routes. The PE router can use just one physical interface and 2 logical interfaces to the PE router, or it can use multiple physical interfaces to the PE router. Okay, yeah, so this is an important thing to understand. On the actual VPN PE routers, you're going to have certain internet tables. Now, the important thing to understand is that on a router, provider edge router serving a customer, where the customer is ordering an internet service, you're going to have a massive BGP table. It's going to have probably 500,000 routes. Yeah. So let's say let's do this. Average size of BGP. Routing table. Oh, wow, okay. That's surprising. Here we go. So this is what I was looking for. Yeah, a full BGP table is about 1 million routes. It's about 1/3 of a million. It's about 3/4 of a million routes. So that's a lot of routes. Big, fat, expensive routers, Cisco ASR, latest and greatest routers. Are what you're going to see. I mean, we can do Cisco service provider routers, and we can see the products they're offering are going to be big, fat, expensive routers. You got to have 1 million routes. So you've got a lot of. So here we go. It's Cisco ASR 9000. Like, look at this. This is as tall as I am right here. So big, fat routers, storing a lot of routes, because you need a lot of routes if you want to provide public internet, because you just have a lot of addresses. I mean, think of it like a phone book. Like, basically, the public internet is a phone book that has everyone's number in it. It's going to be giant. And a VPN is your own custom special phone book just for the people you want to talk to. So it's going to be a lot smaller. Oh, I'm starting to get really hungry right now. But my dinner is coming in an hour and a half when the cron job kicks in. So let's try to keep working up until then. Okay, so that was the 2 non-VRF internet access methods. We also have distributed internet access through layer 3 VPNs. In this scenario, the PE routers provide internet access to the CE routers. In the examples that follow, it is assumed that the internet routes or defaults are present in the inet.0 table of the PE routers that provide internet access to selected CE routers. When accessing the internet from a VPN, network address translation, NAT, must be performed between the VPN's private addresses and the public addresses used on the internet, unless the VPN is using the public address space. This section includes several examples of how to provide internet access for VPNs, most of which require that the CE routers perform the address translation. The routing internet traffic through a separate Nat-device example, however, requires that the service provider supply the NAT functionality using a Nat-device connected to the PE router. In all of the examples, the VPN's public IP address pool, whose entries correspond to the translated private addresses, must be added to the inet.0 table and propagated to the internet routers to receive reverse traffic from public destinations. Okay, so we also have routing VPN and internet traffic through different interfaces for layer 3 VPNs. In this example, VPN and internet traffic are routed through different interfaces. The CE router sends the VPN traffic through the VPN interface and sends the internet traffic through a separate interface that is part of the main routing table on Rudder PE1. The CE router can use either one physical interface with 2 logical units or 2 physical interfaces. NAT also occurs on the CE router, see figure 3, routing VPN and internet traffic through different interfaces. The PE router is configured to install and advertise the public IP address pool for the VPN to other core routers for return traffic. The VPN traffic is routed normally. Figure 4 illustrates the PE router's VPN configuration. The configuration in this example has the following features. Router PE1 uses 2 logical interfaces to connect to router CE1 using frame relay encapsulation. The routing protocol between router PE1 and router CE1 is eBGP. Router CE1's public IP address pool is 10.12.1.1 through 10.12.1.254, belonging to a .0/24 network. The next hop self setting is derived from the fix-nh policy statement on router PE1. PE routers are forced to use next hop self so that next hop resolution is done only for the PE router's loopback address for non-VPN routes. By default, VPN Internet Protocol version 4 IPv4 routes are sent by means of next hop self. You can configure router CE1 with a static default route pointing to its public interface for everything else. The following sections show how to route VPN and internet traffic through different interfaces. So this is configuring interfaces on Rudder PE1. Configure an interface to handle VPN traffic and an interface to handle internet traffic. So we're going to use different interfaces, but it's going to be the same interface. It's just different logical units on the same interface. So we've got different dulce numbers. You can use different VLANs. And then we can see for the, so they each get an IP. Configuring routing options on Rudder PE1. Then we've got a static route. Configure a static route on Rudder PE1 to install a route to the CE router's public IP address pool in inet.0. Okay, then we've got configuring BGP, ISIS, and Ldp protocols on Rudder PE1. Configure BGP on Rudder PE1 to allow non-VPN and VPN peering and to advertise the VPN's public IP address pool. Protocols group, so we're going to connect to the other PEs, so we're going to need 2 neighbor statements in this case. And then we're going to be exporting See, this is the part where my knowledge and my confidence starts to break down. These family statements and these export statements. I'm good with the neighbor statements, I'm good with the local address, type PE, everything perfect. But the family statements and the export statements, I'm really just not in complete control of. So yeah, I think I need an export statement here. That's why I'm confused that Yeah. So yeah, I need a VRF import and export statement. But what did the, oh shoot, I wish I had the, because the documentation I was using didn't have it. Okay, I'm going to include this here. This didn't have it. Yeah, there's no export policy here. I am missing a family INET. Oh yeah, that's a big problem. I'm missing family INET. So here they're using Internet VPN unicast. Okay, that's probably my problem. Yeah, okay, that's my problem. Okay, so that'll make it so that, yeah, so let's grab that, put that in there, and then before I commit that, we're gonna take a look at show route, and we can see that we've got my own static address in here, but we don't have the other static addresses in here. I believe once I enable this family INET unicast, what that statement does is it allows certain network layer reachability information to be exchanged over BGP, and we're going to allow the INET VPN traffic to be exchanged. So I think after I have set that up, we'll either see this table here being populated with the other static routes, or we'll see a new table pop up being populated with the static routes. Ideally, we would see both. We would see a new table pop up, which is like a special BGP VPN table, and then we'd see this one populated. And the reason this one populates is because we were exchanging it using that special VPN table, which has like a /96 or something like that. Okay, so yeah, let's add this to the other ones. Okay, so let's see what's going on here. Aha! So, oh, sorry, never mind. Oh, damn it. Okay, never mind. Never mind times 1,000. Okay, well, shoot. God damn it. Okay, well, it's not up yet. It might just take it some time to come up. I might as well, I'm gonna check it on the route reflector as well. And maybe I misconfigured the family on it. Okay, yeah, we're still waiting for something to come up. Oh, one of them went back to active. I must have misconfigured. Oh, both of them went back to active. Okay, that's interesting. Oh, yeah, I'm missing it from here for some reason. Okay, so one of these should come up now that I fixed that. This one here, the 1.1 should come up. Okay, so let's work on the 1.2. Yeah. Okay, so that makes sense, because I was confused why sometimes we got the BGP table, sometimes we didn't get the BGP table, but it depends on the NLRI that you're exchanging. If you're exchanging NLRI that looks like this, so obviously this doesn't fit in this table, so it's got to be exchanged through its own special table, and that's when the bgp.l3vpn.0 table pops up, is when you're exchanging inet-vpn unicast NLRI, or multicast too, probably. But now we can see, yep, we're exchanging it through this table. We have it in this table now, and now that we have the routes in this table, we also have them in the other table as well. Okay, so it's not as confusing for me now. I was just getting confused by all those different export policies. I thought maybe you needed to export or import routes into a VPN in order for that table to pop up, but nope, that's just complicating things unnecessarily. It's just about that family-VPN. Basically, it's just you can think about the things you're sending through the network, and basically what your NLRI looks like. If your NLRI looks like this, then you're going to need a special table for it. If it looks like this, then you won't need that special table. So I can actually get this table here to populate without needing this table if I would just to exchange family family inet unicast instead of family inet VPN unicast. But the problem with that is I don't get the advantages I get with the L3 VPN, where since they're all prepended with the route distinguisher, all that sort of good stuff, I don't have to worry about those addresses clashing. Like I could have another VPN, and then I could have the exact same addresses in use with that other VPN. Whereas if I used INET, that wouldn't be the case. So okay, it's all starting to come together. All starting to make a lot more sense. I've got about an hour and a half until dinner, so let's keep reading this. Configure ISIS on router PE1 to allow access to internal routes. Configure LDP on router PE1 to tunnel VPN routes. Configuring a routing instance on router PE1. Okay, yep, so this looks really familiar to me. This is what I just did. Now you'll notice here they don't have the route target They don't have the route target statement here. And the reason for that is because they're using more manual VRF import and export statements. Those statements will have the route target in them. So just a different way of configuring it, one that allows for more administrative control than the one I used. And it's really just about filtering out your routes too, because let's take a look at what I've got on here, if I may. So I've just got the VRF target, but they've got import and export policies. So basically I'm just importing everything that belongs to this table here. So show route table VPN .inet.0. Everything here is going to be exchanged through the other networks. So if I do a show BGP summary and then a show route advertising protocol BGP, we're going to see everything. Okay, well, never mind. I thought we were going to see everything that was in here. Why aren't we seeing everything? Is there hidden? Okay. Well, I'm a little bit confused by that because I thought we would see everything. Oh, I see. No, I mean, obviously we're not going to send the BGP routes that we just sent. So that just leaves us with .132 and yeah. Okay, so yeah, that just leaves us with these two routes. So obviously we're not going to be sending the routes that we learned, but this command here, show route advertising protocol, is going to show us everything here. So those ones that we didn't learn, that's going to be what or those ones that we learned, those are going to show up in the receive protocol. Okay, it's starting to come together and make more sense for me now. I don't feel as just sad, lost, hopeless. I feel a lot better right now. Configuring policy options on router PE1. You need to configure policy options on router PE1. The fix-nh policy statement sets next hop self for all non-VPN routes. The redist static policy statement advertises the VPN's public IP address pool. Configure import and export policies for VPN-A. Okay, so we got a new method here, traffic routed by different interfaces, configuration summarized by router. router PE1. So we've got route options, we've got the BGP protocol, ISAS protocol, Ldp protocol, routing instance. So yep, good old stuff I'm really familiar with, VRF, route distinguisher, adding the interface facing the CE to this because it serves as the doorway to the customer. Then we've got a policy here that they're not going to show us, but it basically, oh yeah, it looks like they will show us actually. Yeah, so you can see that we're just accepting. See, this is what really confused me because I thought this is what made it so that those routes showed up in the table or not, but any policy like this is just to filter. Anything that's import is basically just to filter out routes to say you don't want certain routes to be added. And then of course, the other purpose for these sorts of policy statements are redistributing routes. Say, oh, well, I have this, it's an OSPF route, but I want to make it into a BGP route so that it can be sent. So I'm going to export it into BGP. And then here we've got the route target. So, I opted not to do it this way because I didn't want to restrict anything down to the protocol like that. I didn't want to filter out anything. Okay, so I think yep, then we got the, yep, so let's move on to the next one. Routing VPN and outgoing internet traffic through the same interface and routing return internet traffic through a different interface. All right, so that looks good to me. I'm going to take a quick break. I'll be right back. Okay, so I'm back. We're past the 2-hour mark, but it's fine. I can go until 4:30, no problems at all. Routing VPN and outgoing internet traffic through the same interface and routing return internet traffic through a different interface. In this example, the CE router sends VPN and internet traffic through the same interface, but receives return internet traffic through a different interface. The PE router has a default route in the VRF table pointing to the main routing table inet.0. It routes the VPN public IP address pool, return internet traffic through a different interface in inet.0, see figure 5. The CE router still performs NAT functions. Figure 5, VPN and outgoing internet traffic routed through the same interface and return internet traffic routed through a different interface. So CE/PE internet traffic is going this way to the VPN. Public internet, that's part of the regular inet.0 table. Okay, and then VPN. Okay, so the following section shows how to route VPN and outgoing internet traffic through the same interface and routing return internet traffic through a different interface. Configuration for router PE1. This example has the same configuration as router PE1 in routing VPN and internet traffic through different interfaces for layer 3 VPNs. It uses the topology shown in routing VPN and internet traffic through different interfaces for layer 3 VPNs. The default route to the VPN table is configured differently. At the edit routing instances, routing instance name, routing options hierarchy level, you configure a default static route that is installed in vpna.inet.0 and points to inet.0 for resolution. Okay, so everything looks good here. This is going to be the customer connection, so it's a external. Oops, yeah. Oh, I see. So yeah, we're going to actually have 2 different connections now because we're going to have a connection used for the VPN access, but we're also going to have a connection used for the public internet. So I'm actually kind of surprised that. Oh, I see. So what we do is we configure that here, but we tell it, hey, instead of using the VPNA table to serve this, use the inet.0 table. I would have thought you could just configure this in the default routing instance, and then, but you know what? That makes sense, because this interface here we saw hundreds of times can only be added to one routing instance. So if it's in this custom interface, you can't have it in the default routing instance. So you have to do something like next table inet.0, because you can't assign it to more than one table. You can only assign it, because a way to think about a routing instance and is to think of it as if it were a routing table. So we're creating a routing table called vpn.a. There's already an existing routing table called it's not going to be called, it's going to be called vpna.inet.0. This is the routing table that we're creating. Now, if we were to use iBGP to exchange inet/VPN unicast or multicast, whatever, what have you, traffic, we would be creating another table. In that case, we would be creating the bgp.vpn.0 table that we saw here. Oh, sorry, bgp.l3vpn.0 table. But just by this configuration here, what we're doing is we're creating a routing table, vpna.inet.0. So when we do that, we add this interface here, and we say that interface can no longer be a part of the inet.0 table because it belongs to this one instead. So if we want anything traversing through that interface to be serviced by the inet.0 table, the only way to do that is to add this next table command. You also need to change the configuration of router CE1 from the configuration that works with the configuration for router PE1 described in routing VPN and internet traffic through different interfaces for layer 3 VPNs to account for the differences in the configuration of the PE routers. So routing VPN and internet traffic through the same interface bidirectionally. VPN has public addresses. This section shows how to configure a single logical interface to handle VPN and internet traffic traveling both to and from the internet and the CE router. This interface can handle both VPN and internet traffic as long as there are no private addresses in the VPN. The VPN routes received from the CE router are added to the main routing table inet.0 by means of the routing table groups. This allows the PE router to attract the return traffic from the internet. See Figure 6, interface configured to carry both internet and VPN traffic. So we see PE1, yep, VRF interface, okay. In this example, the CE router does not need to perform NAT because all the VPN routes are public. The CE router has a single interface to the PE router to which it advertises VPN routes. The PE router has a default route in the VRF table pointing to the main routing table inet.0. The PE router also imports VPN routes received from the CE router into inet.0 by means of routing table groups. The following configuration for router PE1 uses the same topology as in routing VPN and internet traffic through different interfaces for layer 3 VPNs. This configuration uses a single logical interface instead of two between router PE1 and router CE1. The following sections show how to route VPN and internet traffic through the same interface bidirectionally. VPN has public addresses. Configuring routing options on router PE1. Configure a routing table group definition for installing VPN routes in routing table groups vpn.inet.0 and inet.0. So let's think a bit about what these statements mean. So these statements, inet.0 means you didn't do anything, you just have an interface, and that interface is just configured without doing anything special using the routing instances command hierarchy. but this means you created a routing instance called VRFA. So just by seeing this right here, we know that there is some basic configuration on the router that looks like this: set routing instances VPN-A. We know that configuration exists. We might even know that it is instance VRF, but I'm not sure about that. That would be interesting. Let's try that. So I'm going to go private set routing instances. We'll say VPN-B. Oh, I see. Yeah. So we do know that it's VRF because I can't even create it unless I like this. I have to include like the instance type or some further information. So, all right, so that's the answer. I'll do a rollback 0, get out of config mode, and continue to read. Configure a routing table group. Okay, so I already read that part. Oh yeah. Okay, so this is good because this is RIB groups. This is something I have a lot of trouble with, and I think it was missing from the last lab. I think they meant to do a RIB group because we saw that they wanted to create a neighborship, but they only had inet.3 table populated. So I think what they wanted was a RIB group with inet.3 and inet RIB group applied. Let's see here. So this is VPN-A to inet.0. Where did they want it applied? Yeah, they wanted that RIB group applied to their BGP family, inet, VPN, RIB. Yeah, I don't know, but there's definitely something very, very wrong with that documentation. Okay, so this is configuring routing protocols on router PE1. Configure MPLS, BGP, ISIS, and Ldp protocols on router PE1. This configuration does not include the policy redis-static statement at the edit protocols BGP group PE hierarchy level. The VPN routes are sent directly to IBGP. Configure BGP on router PE1 to allow non-VPN and VPN peering and to advertise the VPN's public IP address pool. Okay, looks good to me. Next part is configuring the routing instance on router PE1. This section describes how to configure the routing instance on router PE1. The static route defined in the routing options statement directs internet traffic from the CE router to the inet.0 routing table. The routing table group defined by the RIB group VPN-A to inet.0 statement adds the VPN routes to inet.0. Configure the routing instance on router PE1. You must configure router CE1 to forward all traffic to router PE1 using a default route. Alternatively, the default route can be advertised from router PE1 to router C1 with eBGP. Traffic routed through the same interface bidirectionally. Configuration summarized by router PE1. This example uses the same configuration as in routing VPN and internet traffic through different interfaces for layer 3 VPNs. This configuration uses a single logical interface instead of two between router PE1 and router CE1. Okay, and it looks like it uses a RIB group, routing options RIB groups, and then it uses, it applies that RIB group to the routing instance BGP for the customer traffic. Okay. All right, so the next way to do it is routing VPN and internet traffic through the same interface bidirectionally, where the VPN has private addresses. The example in this section shows how to route VPN and internet traffic through the same interface in both directions, from the CE router to the internet, from the internet to the CE router. The VPN in this example has private addresses. If you can configure eBGP on the CE router, you can configure a PE router using the configuration outlined in routing VPN and internet traffic through the same interface bidirectionally. VPN has public addresses, even if the VPN has private addresses. In the example described in this section, the CE router uses separate communities to advertise its VPN routes and public routes. The PE router selectively imports only the public routes into the inet.0 routing table. This configuration ensures that return traffic from the internet uses the same interface between the PE and CE routers as that used by VPN traffic going out to public internet addresses. See Figure 7. In this example, the CE router has one interface and a BGP session with the PE router, and it tags VPN routes and internet routes with different communities. The PE router has one interface, selectively imports routes for the VPN's public IP address pool into inet.0, and has a default route on the VRF routing table pointing to inet.0. The following sections show how to route VPN and internet traffic through the same interface bidirectionally, where the VPN has private addresses. So this is configuring routing options for router PE1. On router PE1, configure a routing table group to install VPN routes in the vpna.inet.0 and inet.0 routing tables. Okay, perfect. So we've got another rib group. Yeah, rib groups are really important. It's something that hasn't been on the forefront of my mind. Unfortunately, I think might be able to get me on the test. So hopefully there's more about rib groups later, although I think I did actually already pass that section. I think rib groups was in the BGP routing policy, or oh shoot, where was it? But I think it was long and gone. Was it under? What was it under? I thought it was under the BGP section. Interesting. I thought rib groups were. I thought I went over rib groups before, but perhaps I did not. Yeah, that's interesting. I thought I. Okay. Well, I'm completely confused about that. Okay, so on router PE1, configure a routing instance. As part of the configuration for the routing instance, configure a static route that is installed in vpna.inet.0 and is pointed at inet.0 for resolution. Alright. At the edit routing instances VPNA protocols BGP hierarchy level, configure a policy, import public ADDR to inet.0 to import public routes into inet.0, and a routing table group of VPNA to inet.0 to allow BGP to install routes into multiple routing tables, vpna.inet.0 and inet.0. Configure policy options for router PE1. When the policy options for router Configure the policy options for router PE1 to accept all routes initially, term A, and then to install routes with a public-COMM community into routing table inet.0, term B. Oh man, this one's really complicated. The good news about this is all of this configuration is in help apropos. So hopefully I'll be able to just pull this up and make sense of it during the exam. But you can see it's all marked very clear. Now granted, I am running version 17 on here, and they'll have version 19, but I'm hoping that the difference between version 17 and version 19 is that the documentation is better updated in version 19 than 17, since it's the newer version in version 19. But I could be very wrong from that, and maybe they have found a way to erase all the documentation for the purposes of taking the test. That would be just my worst nightmare. Okay, so if that's the case, I can always make better use of trace options. That's one thing I'm a little bit worried that I'm gonna forget. Recording. Oh no, my video is still recording. It just looks like my camera stopped working. So I can try to get that working again. It doesn't matter. It's just, yeah, I don't think it matters. But we've got a video capture device, so let's see if I can like refresh that or something. Deactivate. Activate. Oh, okay. Yep. So I was just able to deactivate and then reactivate, and yeah, it's working again. Okay. So I don't think it makes a huge difference, but it's just gonna. Okay. So let's continue on. This is traffic routed by the same interface bidirectionally, where the VPN has private addresses. Configuration summarized by Rudder PE1. So yeah, we've got nice group groups, and they're going to be imported where the PECE connection routing instance configuration is. Yeah, so here under protocols BGP. Okay, so that's routing instances, protocols BGP. Here's the policy options. Yep, getting really complicated. Okay, so now this is routing internet traffic through a separate NAT device. In this example, the CE router does not perform NAT. It sends both VPN and internet traffic over the same interface to the PE router. The PE router is connected to an NAT device by means of two interfaces. One interface is configured in the PE router's VRF table and points to a VPN interface on the NAT device, which can route internet traffic for the VPN. The other interface is in a default instance, for example, part of the public routing table INET.0. There can be a single physical connection between the PE router and the NAT device and multiple logical connections, one for each VRF table and another interface as part of the global routing table. See figure 8. Okay, so requirements, M series Rs, yeah, okay, now it's starting to get really complicated. Overview. This example's topology expands upon that illustrated in routing VPN and internet traffic through different interfaces for layer 3 VPNs. The CE router sends both VPN and internet traffic to router PE1. VPN traffic is routed based on the VPN routes received by router PE1. Traffic for everything else is sent to the NAT device using router PE1's private interface to the NAT device, which then translates the private addresses and sends the traffic back to router PE1 using that router's public interface. To route internet traffic through a separate NAT device, perform these tasks. configuring interfaces on router PE1, step-by-step procedure, configure an interface for VPN traffic from router CE1, configure an interface for VPN traffic to and from the Nat-device, Unit 0, and an interface for internet traffic to and from the Nat-device, Unit 1, configuring routing options for router PE1, step-by-step procedure, configure a static route on router PE1 to direct internet traffic to the CE router through the Nat-device. Router PE1 distributes this route to the internet. Configuring routing protocols on router PE1, step-by-step procedure, configure the following routing protocols on router PE1, configure MPLS on router PE1, include the Nat-device on Size VPN interface on the VRF table. Configure BGP on router PE1. Include a policy to advertise the public IP address pool. Configure ISIS on router PE1. Configure LDP on router PE1. Configure a routing instance on router PE1, step-by-step procedure. Configure the layer 3 VPN routing instance on router PE1. Number 1, configure a routing instance on router PE1 as part of the routing instance configuration. Under routing options, configure a static default route in VPN A.inet.0 pointing to the Nat-device's VPN interface. This directs all non-VPN traffic to the Nat-device. Configure the routing policy for the layer 3 VPN routing instance on router PE1. Results from configuration mode on router PE1. Confirm your configuration by entering the show interfaces, show routing options, show protocols, show routing instances, and show policy options commands. If the output does not display the intended configuration, repeat the instruction example to correct the configuration. So these are all just the equivalent of show configuration commands. They're looking at the candidate configuration, though, instead of the active configuration. Okay, so the next way to provide internet access to a VPN is centralized internet access through layer 3 VPNs. This section describes several ways to configure a CE router to act as a central site for internet access. Internet traffic from other sites, CE routers, is routed to the hub CE router, which also performs NAT. Using that router's VPN interface, the hub CE router then forwards the traffic to a PE router connected to the internet through another interface identified in the inet.0 table. The hub CE router can advertise a default route to the spoke CE routers. The disadvantage of this type of configuration is that all traffic has to go through the central CE router before going to the internet, causing network delays if this router receives too much traffic. However, in a corporate network, traffic might have to be routed to a central site because most corporate networks separate the VPN from the internet by means of a single firewall. This section includes the following examples. Routing internet traffic through a hub CE router. Okay. In this example, internet traffic is routed through a hub CE router. The hub CE router has two interfaces to the hub PE router, a VPN interface and a public interface. It performs NAT on traffic forwarded from the hub CE router through the VPN interface and forwards the traffic from its public interface back to the hub CE router. The hub PE router has a static default route in its VRF table pointing to the hub CE router's VPN interface. It announces this static route to the rest of the VPN, attracting all non-VPN traffic to the hub CE route. The hub PE router also installs and distributes the VPN's public IP address space. The configuration for this example is almost identical to that described in the routing internet traffic through a separate Nat-device. The difference is that router PE1 is configured to announce a static default route to the other CE routers. The following sections show how to configure centralized internet access by routing internet traffic through a hub CE router, configuring a routing instance on router PE1, configure a routing instance for router PE1 as part of this configuration. Under routing options, configure a default static route to be installed in vpna.inet.0 and point the route to the hub PE router's VPN interface 10.23.0.1. Also configure BGP under the routing instance to export the default route to the local CE router. Okay. Configuring policy options on router PE1. Configure policy options on router PE1 as part of this configuration. Router PE1 should export the static default route to all the remote PE routers in VPNA, configured in the policy statement's VPNA-export statement under term B. Okay, so internet traffic routed by a hub CE router, configuration summarized by router. Router PE1, the configuration for router PE1 is almost identical to that for the example in routing internet traffic through a separate NAT device. The difference is that router PE1 is configured to announce a static default route to the other CE routers. Okay, so here's an extension. This is routing internet traffic through multiple CE routers. The example in this section is an extension of that described in centralized internet access through layer 3 VPNs. This example provides different exit points for different sites by means of multiple hub CE routers that perform similar functions. Each hub CE router tags the default route with a different route target and allows the spoke CE routers to select the hub site that should be used for internet access. This example uses two hub CE routers that handle NAT and internet traffic. So hub 1 CE router tags 0/0 with community public-comm1 targets 1.1.1.1. And then hub CE2 tags 0/0 with now 0/0 is the default route that they're advertising. So they're each going to be advertising a default route, but that default route is going to be advertised using different community strings. The first one is going to be target 1.1.1.1. The second one is going to be 1.1.2. The spoke CE router in this example is configured to have a bias towards hub 2 for internet access. The following sections describe how configure two hub CE routers to handle internet traffic and NAT. So let's keep an eye out for that configuration. Here it is. So export default. Configuring policy options for router PE1. The policy options for router PE1 are the same as in routing internet traffic through a hub PE router, but the configuration in this example includes an additional community, public-comm1 in the export statement. Okay, so now we've got export default. Oh shoot, where did it go? So here's the VPN export import statements. Yeah, and here's our targets. Yeah, so this export default is going to be using these community statements here, I think. I wish I could. I wish they'd show me that policy. Okay, so this next step is configuring community policy options on router PE1, I think. Oh no, I already read that. So the configuration of router PE2 is identical to that of router PE1, except that router 2 exports the default route through community public-comm2. Configure a routing instance on router PE3. Configure routing instance VPNA on router PE3. Okay. Configuring policy options on router PE3. Configure the VRF-import policy for router PE3 to select the internet exit point based on the additional community specified in configuring policy options on router PE1. Okay, so this is routing traffic through multiple CE routers, configuration summarized by router, router PE1. This configuration is an extension of the example in routing internet traffic through a hub CE router. It provides different exit points for various sites by using multiple hub CE routers that perform similar functions. We got routing instances, routing policies. So yeah, unfortunately I don't see where they define that one policy that I found interesting, but that's okay. Router PE2, the configuration of router PE2 is identical to that of router PE1, except that router PE2 exports the default route through community public-comm2, see policy options. So here's router PE3, routing instances. So this is what I want to see, but they don't have it listed anywhere. Yeah, oh, here it is. Wait, why did I want to see that? Because it's really uninteresting. I guess I thought it would be more interesting than that for some reason. Because I thought it would. Oh, see, I want to see what is exporting a default route. Oh, here it is. Okay, it's right here. This is what's exporting the default route, the VPN A import policy. Okay, yeah, I thought it was going to be this that is exporting the default route, but that doesn't make any sense because that's customer traffic, and it's the default route is not going to be generated by the customer. So you right here you would say these are the customer routes that I want, but here you would say these are the control traffic routes, the routes that I as the ISP am using to accomplish whatever purpose I'm accomplishing. In this case it is establishing internet access. So to do that we're going to be sending a default route, and then we're going to be saying your next hop is the route target here. So yeah, we've got targets :1:111. So anything sent from here is going to have the VPNA _com. I'm so confused. Yeah, I'm like super confused. Well, the good news is that I'm done reading the stuff. Oh, here we go. Here's, okay, so this, I mean, that's huge to be done reading this. Okay, so we're importing anything with this. Oh man, I'm getting hungry, but I've got some food coming. Okay, so I think that's going to do it. Just going to be one video for this topic, but it was a super long video. I would like to get more kind of hands-on, but I think I know what's going on. It doesn't really seem too difficult, and it seems to be a part of the help menu. So, okay, really good news. I finished all of layer 3 VPNs. So I'm going to keep trying to do the pace of at least one topic a day during the weekdays and then 2 topics during the weekends. So I'm going to dive into VPLS next, which is VPLS, layer 2 circuits, layer 2 VPNs, VPNs. That's kind of in my wheelhouse. That's a lot of what I did live hands-on when I worked at an ISP. So I'm hoping this will go faster. Not only that, it looks like I can skip EVPN because I remember doing this out of order at a request of a commenter, so I won't need to go over that again. So yeah, I think I'm doing a really good pace here. After that, multicast I think is going to be a big one, and then the weeks before I take the test. Days before I test, I'll be working on QoS. Okay, so that's it for this video. Stay tuned for the next one when I start VPLS.